Hey guys, Greg Howe here, S9 Radio, and thanks for tuning in. You're listening to a live, over-the-air digital recording of the somewhat rare, highly collectible CP2000 base station 11-meter CB radio. Up until now, you've been listening to the radio with the compressor in the on position. I'm now turning the compressor off. Compressor is now off. I'm using the stock unamplified CPI desk mic made by Turner. I've got the mic gain on the radio set at a level of 2. I've now brought the mic gain up to a level of 3. There's a mic gain at 3. There's a mic gain at 4. Once again, this is without the compression, stock unamplified desk mic level of 5. Now I'm bringing it back down to about 830. I'm going to turn the compression on. As you can see, these radios produce a fair amount of audio for a solid state rig, and they produce a buttload of RF, well over 20 watts, although they sound best with a low dead key and a ton of audio. I'm running this one about 4 watts, swinging just a little past 6.
There were two variations of the CP2000 made, an early version and a late version. It's my best guess there were less than 1,000 of these units produced. The biggest difference between the early and the late version is a different code on the EEPROM that is hiding back down here, and a completely different SMO board, synthesized master oscillator board. Although these printed circuit boards are quite similar, there are some changes, probably some mistakes made on the early version that were corrected on the later version. And then there was a small change on the DC power supply capacitors. They upgraded from a 4,300 microfarad 25 volt electrolytic capacitor to a 4,700 microfarad 25 volt electrolytic capacitor on the later versions. So those are pretty much the only two big differences I can see between the early and the later version. I think I would go for the later version if given a choice, but to be quite honest, CPIs are rock-solid radios with a build quality second to none, utilizing the best quality components and controls money can buy. I mean, look at this front-firing speaker, the big magnet, the nice acoustic suspension. We've got RF beads strategically located throughout the radio to suppress stray RF. Beautiful build quality of the transformer. Good Motorola, National Semiconductor parts. I'm telling you, you just don't see this kind of build quality in 11-meter radios and amateur radios for that matter. This is just very seldom seen build quality. And, Motorola engineers were involved. And consequently, for a radio of better than 40 years of age, they have very few aging issues. The obvious component aging issue is going to be the need for total replacement of all the electrolytic capacitors throughout the radio, a task that should be performed on any vintage piece of electronics. Secondly, these RCA interconnecting cables that connect the various circuit boards together can become problematic over time. The real problem with these RCA interconnections is not so much the cable, providing they've been carefully removed to not put stress on the wire. These circuit board mounted female RCA jacks can be a source of problems, with the main reason being fractured solder at the circuit board due to the torquing and twisting required to remove these cables for periodic maintenance and alignment. The other reason, this is a special type of RCA jack to aid in the flow soldering or wave soldering machine. As you'll see, the outer shell is actually a two-piece design. It's got a crimped mechanical connection that holds this outer shield area to the actual platform. And what this does, it allows less heat transfer and a better solder joint when going through the wave or the flow solder machine. However, this is where a big source of the problems can come from. This mechanical crimp tends to tarnish, it can corrode, and the cigarette smoke can get in there, making this connection extremely erratic. So if you've got any intermittent operation on your CP2000, it's a good place to start looking at these RCA jacks. And the fix for this is either to replace the entire jack with a similar type, or, as I like to do, just throw a little soldering flux on here and run a bead of solder around this outer shell connection, and then go ahead and reflow the solder joints on the actual circuit board, you can see there's some fracturing going on here. For those of you considering replacing the 40-year-old aging electrolytic capacitors on the CPI CP2000, let me tell you, it's a daunting task, even for the most seasoned service professionals, for several reasons. Number one, the solder trace circuit board clearance is so tight, solder bridges are inevitable. Reason number two, these circuit boards were designed by Motorola, and much like the Motorola design circuit boards, they employ a lot of foil, power and ground plane foil. These are plate through holes with the component leads going through. This foil makes it very difficult to get the component leads hot enough to remove the component from the circuit board without pulling or lifting traces. So these boards are easily destroyed. Reason number three is you've got electrolytic capacitors requiring replacement hidden under some of these IF cans, such as L213 right here. I've removed the IF can. You can see we've got an electrolytic capacitor under there. We've got another capacitor there. The CPI did not use a silk screen on the circuit boards, making component identification and polarities very difficult to determine. In a few cases, CPI did put a little dot indicating a positive polarity. I like to use a red Sharpie pen, and then after determining and marking the polarities, take lots of photos on any radio restoration. One dog bark, a phone ringing, any kind of distraction, you're going to be in trouble. So back yourself up, take lots of photos. Like I say, go through with a red Sharpie pen, religiously marking the polarities. You'll be glad you did. And here's another huge headache. This interface board on the front panel has 6 electrolytic capacitors requiring replacement. Removal of this interface board is darn near impossible. This is a welded chassis. It does not come apart. Disassembly of the entire radio is required to remove this interface board, and there's some soldering. It's not a plug and play board. So these capacitors really need to be replaced with the board in place. It's a very tedious operation. And as if that wasn't enough, to complete the total replacement of the 40-year-old aging electrolytic capacitors, you're going to need to get inside this final amplifier assembly to replace the 3 electrolytic capacitors contained within. CPI has installed 2 tamper-resistant rivets that will need to be drilled out to access this assembly. As you can see, this final amplifier assembly is completely detachable from the main frame of the radio. It's enclosed in an all aluminum housing, help dissipate heat from both the driver and the final. And this type of construction also provides some other added benefits, helping keep heat away from sensitive control circuits such as oscillators and crystals that can drift a little bit when the temperature does fluctuate. And it also helps minimize stray RF from the final amplifier from getting into sensitive audio circuits, creating a feedback squeal. On top of that, it allows the test technicians to placing it on a test fixture, and if there is a problem, there's no doubt as to whether that problem is occurring in the amplifier module or the main frame of the radio. Let's have a closer look at the inside of the RF power amplifier assembly on the CP2000. We've got 3 electrolytic capacitors requiring replacement. Not only is age an issue with these caps, heat is a well-known killer of electrolytics. They are located in very close proximity of both the driver and the RF final output transistors, well-known heat generators. And let's not forget about these circuit board mounted RCA jacks that can sometimes be problematic. There are 2 of these connectors inside the enclosure, and these connectors are responsible for both the transmit and receive signal paths. Okay, on to the final. Now I've got to say, in my over 50 years of messing with radios, until the CPI came about, I had never seen a pill case style RF final transistor utilized in an 11-meter CB radio. Now, CPI used a proprietary parts code, so you're not going to be able to convert this number into a generic Motorola or Toshiba RF replacement transistor. Knowing that, I contacted my go-to guy, Merritt, owner and founder of RF Parts. The team quickly got back to me saying that they were 99% sure this was a 40-watt device produced by Motorola back in that era that was very common for HF application. And they were able to give me a positive ID on the also pill-style driver saying that this was a good number that could be crossed over to a generic replacement. So moving on from the final RF output transistors, the signal has to travel through this combiner. Now, I am told that CPI, Communications Power Incorporated, and Palomar have had a long-standing relation. It was actually CPI that designed these combiners that were employed in the early broadband solid-state Palomar amplifier designs. So moving on from the final RF output section, look what we've got here. A true 4-section Chevy-Chev or brick wall low-pass filter. This filter will attenuate the 27 megahertz second harmonic that was so notorious back in the day for tearing up the VHF low portion of the television broadcast band. So you're probably thinking, low pass filter, what do I care? Everybody's cable TV and streaming video nowadays. Well, if you don't have one of these and you're running a solid state amplifier, you probably should care. Because without one of these, you'll have no attenuation of the second, third, and higher order harmonics, which will cause these solid state broadband amplifiers to work harder and run hotter. This spurious output does absolutely nothing for your signal on 11 meters. Yes, it makes the watt meter look a little better, but it's not doing a damn thing for you other than creating a little more heat in the shack. I'm running the stock unamplified desk mic made by Turner, and it's got a really nice compressor built into the radio, although I've got it turned off right now. Everything's running about a number 3 on the mic gain, and just box stock radios. Is it sounding okay?
Sounds excellent, man. Clean, nice, solid, got audio. Really nice, full range of the audio. Signal's good. Sounds really good, Mr. Four.
Hey, 54 Dallas, you copy 388 Big Bear Mountain, Southern California on the Bamboo Quad. Hello. Hey, 54 Dallas, heard you in there and thought you sounded pretty good on this old CPI radio, so I thought I'd give you a holler. Anyways, I know it's busy out there. Hopefully this thing's sounding okay, and with that I'll say 388 Big Bear Mountain, Southern California, Mile High Station.
Okay, 388 Southern Cal with your CPI. Appreciate that, man. You got a mighty nice radio going there for you. Double eight out there around the Big Bear Mountain. Hey, drink double eight. Go clean up man, Chicago on this barefooted Yesu. Come on.
Hey, cleanup man on that barefooted Yesu. Cleanup man on that barefooted Yesu. 388 Big Bear Mountain, Southern California, Mile High Station. I copy. Just threw some more, well, not a few capacitors, a whole bunch of new electrolytic capacitors in this radio, and figured I better give it some talk time and make sure everything is copacetic. So thanks for the get back. And with that, I'll say 73 and 388 Big Bear Mountain, Southern California, Mile High Station.
All right, Mr. 388, sounding good, changing the capacitors, all that, man. That's a good thing to keep up the maintenance work, no doubt about it. Hey, 388, take care. I mean, he's up there, he's up there in Big Bear Mountain.
Surrounded by power lines on 3 sides of the property certainly makes for a noisy radio operating environment. So now the big question is, does the noise blanker on a CP2000 really work? Noise blanker on. I think the results speak for themselves. And now for the ANL, the automatic noise limiter, on, providing an even further reduction in receiver noise, creating a very pleasant receive in what would otherwise be absolutely awful radio operating conditions. Noise blanker on, ANL on. I think it's safe to say the engineers at CPI really nailed this. Okay, guys, that wraps up the review and a few service hints of the CP2000. And I've got to say, being involved in radio for over a half century, I'm predominantly a tube radio guy. I really don't even like solid-state radios, but it is hard not to love these CPIs. They've got this neat flip-out bracket that elevates the front of the radio for those that might be sitting up a little higher in the radio to improve visibility and viewing. They're just overall a beautiful radio. They've got a great receiver, wonderful adjacent channel rejection, the ability to fend off bleed over, excellent sensitivity. I really can't say a bad thing about these radios. So anyways, guys, in closing, I'd just like to mention I've just got the covers set on the radio. They're not actually fastened, allowing me to pop the hood and take some of this video. And I also wanted to mention a few years back, the vice president of CPI put out a video of an interview where he talks, yes, about the CPI radios, but he also talks about some of the collaborations, partnerships, and strange bedfellows of manufacturers and engineering design teams that got together and produced some really great stuff, such as this CPI radio you're looking at right now, which was a collaboration of some of the original Palomar engineering of Escondido, California engineers. As mentioned, there were some Motorola engineers involved, and then some Silicon Valley gurus. So basically, you've got a think tank of some of the best minds in the business, and this radio certainly shows that. The end result of this radio, as mentioned, is just off the charts. So with that, I'm going to say 73 from Greg S9 Radio. Stay tuned. I've got another really interesting video, not the kind of video I like to do for vintage radio. It's on what to look out for and run like hell when you see it. Catch you later.